Lesson 7-4, Dividing Monomials. In the last lesson, we learned how to multiply monomials, and in this lesson, we'll be dividing monomials. Now, the same thing holds true that we need to understand exponential notation. So if we have an exponent and a base, exponents are still called powers and represent repeated multiplication. We went over this in the last lesson, but just to go over it again, 3 to the 4th means that there are 4 3's being multiplied, not that there are 3 times 4. 2 to the 6th means that there are 6 2's being multiplied, and 5 to the 3rd means that there are 3 5's being multiplied. So just be really careful that you don't just say 5 times 3. Okay. When we multiplied monomials, we use the power of multiplying exponents with common bases. When we divide monomials, we'll be using the property of dividing exponents with common bases. And as multiplication and division are opposite, the properties of the exponents are also opposite. When we multiplied, we added the exponents. Now that we're dividing, we subtract the exponents, the top minus the bottom. So here are some examples. X to the 9th over x to the 3rd is going to be x to the 9 minus 3, which gives me x to the 6th. X to the 2 over x to the 10 is going to give me x to the 2 minus 10, which is going to give me x to the negative 8. But we're not allowed to have negative exponents. So what we do at that point is we take the reciprocal. The other way you can think of this is that if you have x squared over x to the 10th, I'm still going to subtract. I'm going to do 10 minus 2. Think of it as a tug of war. The larger exponent is going to win, so that 8 is going to end up on the bottom. We can't have the top empty, so we leave it with a 1. If you have more than one variable or coefficient, you divide like terms. So I'm going to do 18 divided by 3, x to the 12th over x to the 5th, and y over y to the 9th. I'm going to take each of these individually. 18 over 3 is 6, 12 minus 5 is 7, and then 9 minus 1 is 8, and the 9 was on the bottom, so my exponent tug of war lands on the bottom. So here are some more examples. 4 divided by 2 is 2. 2 minus 1 is 1. 8 divided by 2 is 4. 2 minus 2 is 2. And there's a y on the denominator that doesn't combine with anything, so it just stays there. 5 over 10. 10 divided by 5 is 2, but the 10 was in the denominator, so the 2 remains in the denominator. And then x to the 10th over x to the 5th, 10 minus 5 is 5. Here I have a 16 and 20. They don't divide evenly, but they do both divide by 4. Oops, hit my arrow again. Okay, we'll just write that there, divide by 4. So 16 divided by 4 is 4. 20 divided by 4 is 5. 3 and 5. 5 minus 3 is 2, but 5 wins the tug of war, so the 2 stays in the denominator, and then I have a y in the numerator. So why don't you go ahead and pause and try these, and then unpause and check your answers when you've had a chance to finish them. Okay, so the 3 and the 18. 18 divides by 3 6 times. 5 minus 1 is 4. 24 divides by 12 2 times. 3 minus 1 is 2 in the denominator. 2 minus 1 is 1 in the numerator. The 2 and the 6. 6 divides by 2 3 times. X had nothing to combine with, so it just remained. 6 minus 2 is 4. Here, 18 and 24 both divide by 6, leaving me with 3 and 4. X squared over x squared cancel each other out, so there were no x's left. and 4 minus 3 was 1.